Introduction. This unit introduces the term database, its types, and its advantages. It also focuses on basic structure and elements of database. At the end, it provides solid concept of entities. Objectives. The objectives of the unit are to explain importance of database course, database concept, various architectures of database, the cost, risk, and environment of database management system, difference between data and information, the concept of entity and attributes, various types of attributes, how entities are recognized in an entity type, how various entity types are associated with one another. Database introduction. Every organization in the real world is like a system, which requires resources in order to fulfill its main objective. These resources are: number 1, physical resources such as human resource, equipments, etc. Number 2, logical resources such as data. It is very difficult to rely on physical resources. For example, if it is required to check the course registration of a particular student, it is unusual to call a student for verification. Similarly, if it is required to check the balance of a particular item in the stock, it is again unusual to start counting the items available in the stock and then subtract from the total figure. Therefore, we can say that dealing with huge amount of physical resources, we must rely on the logical resources, that is data. So it becomes easy for us to check the record of student registration and similarly check the data of item in the stock. Therefore, in today's modern era of information technology, data is considered to be one of the most important resource and asset of an organization. If an organization fails to recognize the data, it will not be able to work properly and efficiently. Realizing the fact, database management system has emerged as one of the most important courses in the information system curriculum today. Therefore, most of the business organizations keep their data in an organized shape in databases. Now let us define the term database. It is an integrated collection of data shared by many legal users. To understand what is database, we need to understand integration, sharing, security. Integration. Every system in the real world is found in the integrated form, such as a faculty in university is the integration of many related departments. Each one is easy to administer and manage. The database is also like a system, which is not simply a large collection of data in a single reservoir, but rather the integration of many organized units. Sharing. The data in database is stored at one place and is used by a number of users. So it is a shared resource among number of users. Security. Unauthorized user cannot access the data stored in the database. Types of databases. The databases are classified broadly into two groups. These are: number 1, according to architecture, number 2, according to functional units. Let us discuss each one in more detail. According to first classification, there are further subtypes of databases. Personal computer database. This type of database is developed on personal computers. For example, consider a company that has a number of salespersons. Each has many customers. Each salesperson might carry a laptop computer with a simple database application to record customer information and the details of contacts with every customer. Let us now discuss some important characteristics of personal computer databases. These are: number 1, it satisfies the need of only one user at any given instant of time. Number 2, it is implemented on stand-alone personal computers. Number 3, it is simple to design and develop. Number 4, it is widely used. Number 5, it is low cost. Central computer database. This type of database is developed on mainframe or mini-frame computers. Let us now discuss some important characteristics of central computer database. These are: number 1, it satisfies the needs of many users at any given instant of time. Number 2, It is implemented on mainframe or mini-frame computers. Number 3, it has complex design and development. Number 4, it is costly than personal computer database. Number 5, covers medium scale as well as large scale organization. Today, most of the organizations are moving away from central computer databases as the environment of mainframe or mini-frame computers is very costly in terms of initial investment and maintenance. Client-server database. This type of database is developed on client-server architecture, that is local area network. Let us now discuss some important characteristics of client-server database. These are: Number 1, it satisfies the needs of many users at any given instant of time. Number 2, it is implemented on client-server architecture. Number 3, it is costly than personal computer database but cheaper than central computer database. Number 4, it covers medium-scale as well as large-scale organizations. Most of the organizations are opting client-server databases as the client-server environment is affordable and efficient. Distributed database. This type of database is developed on wide area network and suitable for those organizations which are operational in widely spread geographical locations. Let us now discuss some important characteristics of distributed database. These are: Number 1, it satisfies the needs of many users at any given instant of time. Number 2, it is implemented on wide area network. Number 3, the design and development is complex. Number 4, it is costly than client-server databases as communication channels are involved. Number 5, it covers medium-scale as well as large-scale organizations. Now let us discuss the second classification, that is according to functional units. There are further subtypes of databases. These are personal computer databases. The personal computer databases also fall in this category without any change as discussed in first classification. Workgroup databases. A workgroup is a relatively small team of people who collaborate on the same project or application or on a group of similar projects or applications. A workgroup typically comprises fewer than 25 persons. Each member of the workgroup has a desktop computer and the computers are linked by means of a local area network. The database is stored on a central device called the database server, which is also connected to the network. Department databases. A department is a functional unit within an organization. Typical examples are human resource, marketing, manufacturing, and finance. A department is generally larger than a workgroup, typically between 25 and 100 persons. Each member of the workgroup has a desktop computer and the computers are linked by means of a local area network. Enterprise databases. The enterprise database is one which scope is the entire organization or at least many different departments. Such databases are intended to support organization-wide operations and decision-making. A single operational enterprise database is impractical for difficulties in performance, diverse needs of different users, and the complexity of achieving a single definition of data for all database users. An enterprise database does, however, support information needs of many departments. The most important type of enterprise database today is called a data warehouse. A data warehouse is an integrated decision support database whose content is derived from the various operational databases such as personal computer, workgroup, and department databases. The enterprise databases are implemented on local area network or wide area network. Consider a large healthcare organization that operates a group of medical centers including hospitals, clinics, and nursing homes. Each of these medical centers may have separate databases to support the various operations at that facility. These databases contain data concerning patients, physicians, medical services, business operations, and other related entities. The databases provide adequate support for most functions at each individual medical center. However, the organization has increasingly realized the need for a single consolidated view of the entire organization. This body of data is required for corporate decision making. Therefore, the organization creates a data warehouse maintained at the corporate office. Data in the data warehouse are derived by extracting and summarizing data from the individual databases on a periodic basis and transmitting those data by means of a telecommunications network to the corporate data warehouse. Advantages of database approach. Now we will discuss major advantages of using database approach. These are data independence. The data modification is a normal practice in any organization, such as increase in the salary. Therefore, it is wise to keep data separate from the application programs that use it. This separation of data from the application program is called data independence. Dear learners, as you know that with the database approach, data is stored at a central location called repository. This property of database system allows an organization's data to change within limits without changing the application programs that process the data. Consider a computer program to calculate the bonus, which is currently 5% of monthly sale. If the rate of bonus is raised to 7%, then the computer program is required to change to incorporate the change in the data. The program needs to be recompiled and run. This change of software is useless and can be avoided by storing the data separately in the database as shown. Now, if there is any change in the data, that is 7% raise of bonus rate is modified easily in the database without changing the actual software. Minimal data redundancy. Data redundancy means a data item is stored at multiple locations. For example, record of students is stored in the examination department as well as in the academic department he or she is studying in. Dear learners, as you know that database is a shared resource. Therefore, the student records are stored at a common location and is accessed by examination department as well as academic department. Now it becomes clear that adopting database approach controls the duplication of data. Improve data consistency. Eliminating or controlling data redundancy, we greatly reduce the opportunities for inconsistency. For example, if address of a particular student is stored only once, there is no disagreement on the stored value. Also, updating data values is greatly simplified when each value is stored in one place only. Improve data sharing. Dear learners, as you know, the database is a shared corporate resource. Authorized users are granted permissions to use the database. Increase productivity of application development. There are a number of productivity tools available such as query languages, forms, and report generators. These tools greatly reduce the cost and time for developing new business applications. Enforcement of standards. When the database approach is implemented with full management support, the database administration function should be granted single point authority and responsibility for establishing and enforcing data standards. These standards will include naming conventions, data quality standards, and uniform procedures for accessing, updating, and protecting data. The data repository provides database administrators with a powerful set of tools for developing and enforcing these standards. Improve data accessibility and responsiveness. Dear learners, as you know, the data is stored for a reason that it must be available when needed in various forms. The user requirements may have many forms related to stored data. For example, head of department needs to know the top position in a particular course. Next moment, he may need to know the average result of that course. The data once stored in a database can be quickly accessible and can be manipulated accordingly. Reduced program maintenance. The updating of stored data is a frequent practice for a variety of reasons. New data items are added, data formats are changed, and so on. In a database environment, data are more independent of the application programs that use them. Within limits, we can change either the data or the application programs that use the data without necessitating a change in the other factor. As a result, program maintenance can be significantly reduced in a modern database environment. Costs and risks of database approach. The database approach entails some additional costs and risks that must be recognized and managed. These are new specialized personnel. Frequently, organizations that adopt the database approach need to hire or train individuals to design and implement databases and to provide database administration services. Because of the rapid changes in technology, newly hired people will have to be retrained or upgraded on a regular basis. An organization must not minimize the need for these specialized skills. Installation and management cost and complexity. A multi-user database management system is a large and complex suite of software that has a high initial cost, requires a staff of trained personnel to install and operate, has substantial annual maintenance and support costs. Installing such a system may also require upgrades to the hardware and data communication systems in the organization. Substantial training is normally required on an ongoing basis to keep up with new releases and upgrades. Additional or more sophisticated and costly database software may be needed to provide security and to ensure proper concurrent updating of shared data. Conversion costs. The term legacy system is widely used to refer older applications in an organization based on older database technology. The cost of converting these older systems to modern database technology is measured in terms of money, time, and organizational commitment. Need for explicit backup and recovery. A shared corporate database must be accurate and available at all times. This requires comprehensive procedures for providing backup copies of data and for restoring a database if damage occurs. Organizational conflict. A shared database requires a consensus on data definitions and ownership, responsibilities for accurate data maintenance. Experience has shown conflict on data definitions, data formats and coding, rights to update shared data. All these issues are frequent and often difficult to resolve. Handling these issues requires an organizational commitment. Components of database environment. Dear learners, the major components of a typical database environment and their relationships are computer-aided software engineering tools. These are automated tools used to design and develop databases. Repository, centralized storehouse for all data definitions, data relationships, screen, report formats, and other system components. A repository contains an extended set of metadata important for managing databases as well as other components of an information system. Database management system. Commercial software systems are used to define, create, maintain, and provide controlled access to the database and also to the repository. Database, an organized collection of logically related data usually designed to meet the information needs of multiple users in an organization. It is important to distinguish between the database and the repository. The repository contains definitions of data, whereas the database contains occurrences of data. Application programs. The computer programs used to create and maintain the database and provide information to users. User interface. Languages, menus, and other facilities by which users interact with various system components such as case tools, application programs, the DBMS, and the repository are called user interface. Data administrators. The data administrators are persons responsible for the overall information resources of an organization. They use case tools to improve the productivity of database planning and design. System developers. The system developers are persons such as system analysts and programmers who design new application programs. System developers often use case tools for system requirements analysis and program design. End users. Persons throughout the organization who add, delete, and modify data in the database and who request or receive information from it. Data. Dear learners, After discussing the database definition, types, cost, and components of database, now it is time to discuss the backbone of database, that is, data. Historically, the term data referred to known facts that could be recorded and stored. The word data refers to facts concerning things such as people, objects, or events. For example, list of students as shown. Similarly, in a salesperson's database, the data would include facts such as customer name, address, and telephone number. This definition now needs to be expanded to reflect a new reality. Databases today are used to store objects such as documents, photographic images, sound, and even video segments, in addition to conventional textual and numeric data. For example, the salesperson's database might include a photo image of the customer contact. It might also include a sound recording or video clip of the most recent conversation with the customer. To reflect this reality, we use the following broadened definition. Data consists of facts, text, graphics, images, sound, and video segments that have meaning in the user's environment. Information. The data is raw collection of facts and figures related to something. This can be useful only if refined and reflects a meaning. This refined shape of data is called information. It is knowledge derived from data. For example, the given table gives us information that is 2 students enrolled in database major, 1 student enrolled in networking, and 1 student enrolled in programming. Metadata. We just learned that data become useful only when placed in some context. The primary mechanism for providing context for data is metadata. Metadata are data that describe the properties or characteristics of other data. Some of these properties include data definitions, data structures, and rules or constraints. For example, in the given table, the registration number, name, class, and city are the metadata. Entity. Every system is composed of many objects, such as persons and events. For example, a university is composed of employees, students, courses, course registrations, etc. The individual object in a system is called an entity class or entity type. The individual entities are sometimes very large in numbers in a system. For example, students in the university are usually large in numbers. The large number of entities is very difficult to manage. Therefore, such large number of entities is always grouped, which is called an entity class. Every entity always belongs to an entity class. An entity may belong to more than one entity class. For example, a faculty member belongs to employee class as an employee, as well as may belong to a student class if registered for PhD degree program. Similarly, a physician in a hospital belongs to physician class as a physician, as well as may belong to patient class if hospitalized. Attributes. Each entity type has a set of attributes associated with it. An attribute is a property or a characteristic of an entity type that is of interest to the organization. For example, the entity type student has attributes registration number, name, address, and phone number. Similarly, the entity type automobile has attributes registration number, color, type, and model. Let us now discuss recommendations for naming the attributes. Use an initial capital letter followed by lowercase letters. For example, name, registration number. If an attribute name consists of 2 words, an underscore character is used to connect the words. Each word is started with a capital letter. For example, employee name. The actual values are assigned to attributes of an entity class. No value can be stored without attributes for an entity. Each instance of an entity type has a value associated with each of the attributes of that entity type. This is shown as: there are 2 entities in the given entity class student with their respective attribute values. Types of attributes: simple versus composite attributes. Some attributes can be broken down into meaningful components. The most common example is address, which can be broken down into components such as street number, house number, town, and city. Composite attributes provide considerable flexibility to users. It can either be referred as single unit or referred as its individual component. A simple or atomic attribute is an attribute that cannot be broken down into components. For example, all of the attributes associated with automobiles are simple: registration number, color, type, and model. Single-valued versus multi-valued attributes. A single-valued attribute has one value for an entity in an entity class, while multi-valued attribute has more than one value for an entity in an entity class. Consider the entity class student. There are two entities with their respective attribute values. For each entity instance, the attribute registration number, name, and program has one value, that is, attribute registration number has value 1, attribute name has value Arsalan, and attribute program has value BS. Such types of attributes are called single-valued attributes. It frequently happens that an attribute may have many values for a given instance. For example, the entity type student has an attribute courses, which may have many values for an instance, that is, an instance with registration number 1, name Arsalan, and program BS registered 3 courses: DBMS, C++, and networking. Such types of attributes are called multi-valued attributes. Stored versus derived attributes. Stored attributes are those attributes whose values can be stored. The derived attributes are those whose values could be calculated from other related attributes and are not required to be stored. For example, the entity type student has a birth date attribute. If it requires knowing the age, it can be calculated using birth date and today's date. Now it is clear that a derived attribute is an attribute whose value can be calculated from stored attribute values. Key. An entity class may have a large number of entities. The recognition of single entity or group of entities in an entity class is very important. Look at the entity class student as shown. If it requires to know the program of a student, it becomes necessary to recognize the individual entity. Similarly, if it is required knowing all students belonging to city Peshawar, the group based on city becomes necessary to recognize. The key could be used to recognize the individual or group of entities in an entity class. Now it is time to define key. A key is a single attribute or a group of attributes used to recognize individual entity or group of entities in an entity class. For example, in entity class student, attribute registration number could be used to recognize an individual entity. Similarly, attribute city could be used to know the list of students belonging to Peshawar. Let us discuss key in more detail by discussing various types of keys. These are primary key. It is a single attribute used to recognize an entity in an entity class. For example, in entity class student, the attribute registration number is a primary key. The primary key attribute is represented as underline. Now a question arises: why attribute registration number is chosen as primary key? This can be clarified by discussing characteristics of attribute to be selected as primary key. These are: number 1, it is always defined. Number 2, it is only one. Number 3, it has unique value for every instance, and number 4, it must have a value. Composite key. It is group of attributes used to recognize single entity in an entity class. Thus, a composite key is basically a primary key composed of more than one attributes. For example, consider the entity class student as shown. In this example, any of the attribute cannot be used as primary key as duplication exists which is not allowed in case of primary key. Combining different attributes whose collective value shall recognize the single entity in an entity class can solve this problem, such as roll number plus shift recognize single entity in entity class student. Now let us discuss the characteristics of composite key, which are: number 1, it is always defined. Number 2, it is only one. Number 3, the collective value must be unique for every instance. Number 4, the value of attributes of composite key is mandatory. Alternate key. It is single attribute other than the primary key, used to recognize single entity in an entity class. It is also called candidate key. Consider the example as shown. The attribute passport number is an alternate key by assuming that attribute registration number is defined as primary key. The characteristics of alternate key are: number 1, it is not defined. Number 2, the value of attribute to be used as alternate key must be unique value for every entity instance. Number 3, the value is not mandatory. Secondary key. It is a single attribute or group of attributes used to recognize group of entities in an entity class. Consider the entity class student as shown. The attribute city can be used as secondary key, knowing all the students belonging to Peshawar. Any part of the composite key can also be used as secondary key. For example, in the entity class student as shown, the attribute shift can be used as secondary key, knowing all the students of morning shift or evening shift. The characteristics of secondary key are: number 1, it is not defined. Number 2, it may be more than one. Number 3, the primary key or composite key cannot be used as secondary key. And number 4, any part of the composite key can be used as secondary key. Sort key. It is a single attribute or group of attributes used to organize and access group of entities efficiently. Consider the example as shown. If it is required to access all students belonging to Islamabad, the search is started from first entity and continues sequentially till the end of entities. All the entities matching the criteria are accessed. It takes long time and all the entities must be read and compared against the desired access. This longer access can be made efficient by organizing the entities by desired attribute such as city in student entity class. The organized entities are shown as: now if it is required to access all students belonging to Islamabad, the search is started from first entity and continues sequentially till the last matching entity. All the entities matching the criteria are accessed. The remaining entities are not searched for desired entities, as there is no chance for such existence. Dear learners, remember that only secondary key attribute can be used as sort key. Index key. It is an attribute used to access a single entity efficiently from an entity class. Consider the entity class student as shown. If it is required accessing Daniel, whose registration number is 2, the search is started from first entity and continues sequentially till the desired matching entity or end of entities encountered. The desired entity is found in fifth matching. The same desired entity could be accessed by organizing the entities on primary key or composite key or alternate key, such as attribute registration number in entity class student. The organized entities are shown as: now if it is required accessing Daniel, whose registration number is 2, the search is started from first entity and continues sequentially till the desired matching entity or end of entities encountered. The desired entity is found in second matching. Thus, the number of matches are reduced. Data association. Dear learners, as you know that every system is composed of entity classes which are not isolated from one another. Therefore, they interact with one another. This interaction builds useful systems in the real world. This logical link of one entity class with another entity class is called data association. Now it is clear that an isolated entity class is meaningless and not productive. For example, The entity student is linked with entity class faculty member, as well as courses and many other. The logical link is represented graphically as shown. Now let us discuss various types of association in detail. One-to-one association. An instance of one entity class A can be associated with exactly one instance of another entity class B. The graphical representation is shown as. Consider the example by assuming that a student can take only one project in the final semester. This is represented graphically as shown. The sample instances are shown as. The student Arsalan takes project examination system. The student Daniel takes project admission system. The student Fawad takes project fee system. One-to-many association. An instance of one entity class A can be associated with many instances of another entity class B. The graphical representation is shown as. Consider the example by assuming that a project can be taken by many students in the final semester. This is represented graphically as shown. The sample instances are shown as. The project examination system is taken by students Arsalan and Daniel. The project admission system is taken by a student Khalid. The project fee system is taken by students Fawad and Sana. Many-to-many association. Many entities of one entity class A can be associated with many entities of another entity class B. The graphical representation is shown as. Consider the example by assuming that many students take many courses. The sample instances are shown as. The student Arsalan takes 3 courses, C++, DBMS and Java. The student Khalid takes 3 courses, C++, networking and communication. The student Fawad takes 2 courses, Java and operating system. Data structure diagram. The logical link of entity classes is not restricted to 2 entity classes. Rather, it can be extended to any number of entity classes, which collectively build systems. The graphical representation of such entity classes is called a data structure diagram. Consider the example. A customer orders for many products. A product may be ordered by a number of customers. In this example, there are 3 entity classes: customer, order, and product. The data structure diagram is shown as.